Hello everyone and happy Friday. Thanks for joining me again today. On my agenda today is drakon render again. And what I'm going to try to finish is the position function, which assigns an origin to all of my skewer blocks. So for those of you who watched the last session, I stumbled upon this function not working recursively. It just goes through the only this collection of skewer blocks, and it doesn't dive into its children and those children's children, etc., etc. So we'll try to correct it today if time allows. So I hope you have your coffee or tea or whatever your drink of choice could be ready. And let's dive into the code. What I think the inspiration for this function should be is change origin should work a little bit like the render function, where it assigns origins to children blocks of a fork. I think it only applies to a fork. So the left-hand side of a fork we render here, and we need to just calculate L origin. And right origin. Okay. So something like this will have to apply in change origin of a fork. This is just a placeholder. We'll have to generate new L and new right with changed origins. We don't necessarily need this. We don't need this. We just need to borrow quote unquote origins from this function. I'm hoping for the format script to deal with all these inconsistently formatted lines. So we have a new origin, which we'll have to deconstruct. And question we need to build from here. And again, I'm not striving for perfection here. I just want us to get closer to the stage where in the first sweep through the provided skewer blocks, we position them and we isolate a map of skewer blocks so that they can be identified by ID. Remember what we started earlier this week? And in the second sweep, we render them. We generate the connections between them that result from their natural relationships. And we generate also the extra connections that the user provides in the drakon diagram type. So we still have a little bit of work to do. Well, maybe a little bit more than a little bit. So this gets a new origin. So we have the L origin and R origin, which should trigger some warnings if we try to compile it. But I think this will build. Famous last words. 68. Okay. I think conceptually it should build. No. 69. Content. Hold on. It should be content. Let's see what else it breaks. Yep. 197. What else? 120. Where is that content used? To build a question, but since question now accepts the content, we can simplify it. 108, which is somewhere here. Now we need to destructure it. Let's not worry about these warnings for now. So what we can do now is to call the position function on L with L origin. And Let's see what happens. And position prime. And the same for R. R origin. And this becomes new L, new R. So I'm hoping this should resolve the recursive positioning problem. Let's see if I'm right. Where's Firefox? Here. And it does, I think. It does. All right, let's just double check if these are positioned correctly. Well, naturally they are, otherwise we wouldn't be able to see them. 0, -3, -4, -5, -8, which would leave space for -7, -6, correct? All right. It looks like we might be home. Let's remove this. This comment stays. Yes, we will. Let's close all these and format. So the position function is not looking too bad. I mean, the beauty of it is that it hasn't changed, or we didn't have to touch it today. What it did have to touch is change origin for the fork implementation. But I think it's pretty elegant. I mean, can it be simplified? Absolutely, but it's pretty elegant already, I think. All right, so let's reassess the situation. We have the render prime, we have the position prime, which means that in the render function, we no longer have to worry about calculating positions. Let's see what the second accumulator is used for. So this is for rendering connections. Now, what we could use is the printout. You know what? Before I do that, let us get rid of these horrendously looking additional connections. We do not need them. They are just blurring the picture. Oops, no. Okay, perfect. Let's try to render also the position or the origin of forks and of start and here we would have question ID, origin, and just content. So hold on. Action ID. Do we need this for anything else? Oh, no. Let's not do that. Let's do show question action ID. Or X or Y. Okay, this could be good. Line 70. So we don't need this. We can just get rid of it. All right, now forks also have the origin printed out. Zero, 3, 0 minus 5, 3 minus 5, that's correct. Let's not worry about the start and end for now. Now, what we do need is two things. One, the map of all skewer blocks, and also their unique IDs. Okay, this is not looking bad. Now, we could get started on the map, but let's remember the key in the map is, is the ID, which means that as we insert elements into a map, they would just overwrite each other. That's probably not the smartest move. So let's remake this diagram with concrete types or concrete type values as opposed to just a string. So now we parse it, and we don't have a parser implemented for IDs yet, and I'm planning to delay it for as long as I can. I want to focus on lexical analysis and parsing only after I have a firm understanding of all the nuances of all types. All right, so let's build a new diagram. So we have a title, custom content title, no skewer blocks, and end. Oh, now I don't have to worry about positioning, which is probably not ideal in this scenario. I should just be able to skip origins if I don't know them. And when I just provide the content like that, I don't know them. But it will be changed anyway, so by the change origin function, so I don't have to worry too much. So no custom connections. Let's just create an action. the same origin. We don't need to print these skewers. Okay, let's see how this works. Oh, we're missing IDs, of course. So let's take a sneak peek at those types. Action. ID, origin content. So the title would also have an ID. So let's try to be smarter than just giving natural numbers to all identifiers. Let's mark each level as a multiply of 100. And so title will be 100. Action will become 200 and will become 300. And does not have an ID. And it should, I think. We could print the position of it, and let's do that. Why not? This will definitely break something. I'm going to import it. Thank you. ID origin content. Now, parsing. 83. Oh, that's not even parsing yet. Third argument of, oh, that is content, just a string. Content. Thank you. Now this guy. $93.53. Okay, we have a title. Does title not have an ID? Yep, no ID. And also let's print out its ID if we're in troubleshooting mode. Okay, and this will have to be renamed, not to cause a clash with the function ID. What about contents? Oh, this is also a string. Okay, so we just need to make one more import. Thank you. Helper diagrams, I think we've already cleaned up when it comes to imports. IDs, I think we did as well. Valent point also seems done. Type classes seems to be done. So we only have start terminator and skewer block to clean up. Oh, main 88. And naturally the ID. It really pains me to hard code all these IDs as -1s. But for now, as I said, I don't want to focus too much on parsing. That will come and it will be its own separate adventure. And it will be interesting. Also, where's the title? Yeah, here. And obviously, this needs to become content. There's a lot of things, or there are many things that we don't parse. The origin, so it's made up. The ID, so it's made up. The content, so it's made up. So there's a lot of work ahead of me still. Main 88. .94. That's interesting. Render new diagram. Do we need to origin? No. It works here. Let's see, 34. So it looks like we'll need to revert that change. Both in line 88. Oh. I mixed up the argument ordering. Okay. Let's try to run it now. And we should be seeing some IDs. Ooh. Okay. This is looking well, but just in case, in constants, let's reduce the font size. Okay. So we do have IDs that are different. We have positions that look correct. And we have this, all of this printed out in troubleshooting mode. Okay, so good progress today. I'm pretty pleased. Looking at the time, do we have the time to generate a map out of it? No. Maybe let's leave it for the next session. For this session, let's just add a fork. Do the new diagram so we know what we're working with. Or well, we do know what we're working with, but to sort of provide a hook for next week. Oh, this is not looking bad. So here, fork. The ID is going to be 201. Then the origin, which is made up, and content. And also, let's not forget the left and the right. So I'm just going to borrow this action. And children are on the new level. So let's go to 10. And to 11. Oops. And let's see how that looks like. So we should basically have a fork in between these two steps. Okay, and we do. Let's check the IDs. 100, 200, 201. No, that is wrong. It should be 210. The fork should be 210. And its children, it should be 220 and 221. Okay, let's double check. 100, 200, 210, 220, 221, and 300. Okay. I think this is good enough for today. I'll commit this shortly. And yeah, I think we'll wrap it up for now with the prospect of skewer block here. With the prospect of also implementing a to-map that goes through this list, but also recursively. And once we have that, we'll modify the render function to finally not only render the icons and their natural connections, but also the extra connections identified by this list. This list that we still have commented out. But I need a little break before that. So let's wrap it up here for now. I thank you all very much for tuning in today. I wish you a fantastic weekend ahead. I hope you get to spend some time with your family and friends, recharge your batteries, enjoy maybe some coffee or two. Yeah, I'll see you next time. Take care. Bye.